everyone. In this video, I wanna give you a little bit hint or help in terms of how you are able to finishing this problem related to assigning project leader to the client. So based on the case description video, you are already able to understand the objective function, and then the constraints, and then how we define the variables. And so now in this video, I want to give you a little bit of help or help you to validating the Excel file you already set up by yourself. So to answer this question, like usual, we need to set up three tables. The parameter table. So that will be my table 1. Okay, so in this video, so in this first table, and then as we know, this is related to the time of assigning project leaders to each client. So we have 3 project leader and 3 client. So we have X11 representing, remember, is the completion time for tariff they assign to the client 1, right? So 1, 2, X13, X22, X21. So that is related to Carly. X22, X23, X31. So this is the project leader Mac Lemond. X32, X33. Okay, so this all for the parameter here is related to the completion time, right? And then that is related to it's measured by days. Okay, so now I start put a value for my parameters. So X here will be 10, 15, 9, 18, 5, and 6, 11, 3. Okay, so this is my first table. It gives us information about the 2 project leader along with the so why it doesn't work? Okay, so somehow it didn't work the colors. Okay, so this is related to the project leaders versus the client. So the table number 2 as before. So for the table number 2, that will be our choice variable or decision variable. Okay, so for the decision variable, we just need to copy. So those are my decision variables, right? And then so for this table here, and then so the here will be X11, X12, X13. So those are representing my choice variable. Some students say, hey, Dr. J, here X11, X12, that is related to which project should be assigned to which leader. So is this X11, X12, X13 actually means the fraction of the project? The answer is no. So when after we use the solver to solving this problem, given the constraint we're gonna set up, and you will notice that among X11, X12, X13, only have one of these 3 gonna be 1, similar to X21, X22, X23. So basically among all these 9 choice variables, we're gonna end up only have 3 ones because each leader will assign 1 or 2 or 3 projects, so they are not assigned a fraction of the project. But we still set a problem like this. So the way we define X11, 12, etc., we define as the project is assigned to that specific project leader. Okay, so this is table number 2, and I'm going to look at the table number 3, my objective function. Okay, so for this one, we are minimize the completion times. Okay, so for this objective, so that will equal to, so basically we can use sum product to make it a little bit easier because we are using each of those coefficients. That's going to be my first array, and then this is going to be my second array. Okay, oh sorry, this blank cell in my table 2 will be my my second array. Okay, so you can do this way, or the other way would be equal this time this plus 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 this times, oh, sorry, there is a typo here, should be this time this time this plus this times this plus this time. So there's many. Okay. Okay, so when we're solving this problem, and then you will see the value here tell us so which project will be assigned to which one. So this project, okay, so you can either use sum product, or you can just literally just using the exact same expression you have on the initial write down that objective function. So I prefer to use sum product here because it's relatively clean. Okay, now I'm going to my table 4. I'm gonna list all my constraints. Okay, so the first constraint we will have here is basically telling us the we have a requirement. So the first 3 constraints are related to our group leaders. So for each group leader, they should be assigned no more than 1 project because that limit the capacities. So each leader will be only assigned 1 project. So therefore, the first constraint is related to Terry's assignment. And then so here will be on the left hand side will be the time of completion. And then the middle one will be operator. And then the right hand side will be limits. Okay, so if you look at this, so the time completion for Terry, so that is related to all the completion time with x11, x12, x13. So therefore you can use sum. Oh, sorry, sum of the completion time. Okay, so sum of the completion time, x11, x12, x13. So for this has to be smaller and equal to 1 because they should assign no more than 1, so they can assign nothing, right? So the other one is person is Collie's assignment. So for this one will be the sum, the x21, x22, x23. Okay, so for this one has to be also smaller and equal to 1. And then the last leader is McColomat's assignment. Similarly, for this one, has to make sure x31, 32, and 33 together, add all of them together, has to be smaller and equal to 1. And now we start talking about client. So since you're your client, we have to make sure all their project will need to be fulfilled. So therefore, for this following 3 constraints, they has to equal to 1. So each client must have 1 assigned project leader, right? So therefore, the client 1, so that will equal to, so client 1 is relevant to x11, x21, and x31. So this has to equal to 1. Oops. Okay, so when you type equal in the Excel, it's a good idea to put a 1 single quotation mark and then type equal so that they will treat it as equal sign as a word versus using as a way to starting an equation. So this equal to 1. Okay, client 2. So this will equal to x12 plus x22 plus x32 because if the second number is 2, that is related to the client 2. So this has to be also is equal to 1, and our client 3. Similarly, so that is if the second number is 3, that's equal to our client 3. So that will be x13's value plus x23's value plus x33's value. So similarly, this one has to be equal 1. This could allow us to make sure all the client will be assigned a group leader, and then also the non-negativity constraint. Okay, so now we set a problem, and then let's do it using the data solver. Okay, so my objective function, first of all, is minimize. We try to minimize the completion time. And then so for my objective here, I need to select my B9. Also, you can use the other option, right? So this is gonna be in my table number 3. That is where we're getting our objective function. And then for the choice variables, that's in our table number 2. And I will select the value here under x11 until x33. And now I'm start adding my constraint. I'm gonna click add. On the left hand side, since the first 3 constraints have the same operator, and it's a smaller than or equal to, and then on the right hand side will be those ones. And then I will click add, and I'm gonna add in the last 3 constraints on clients, and then changing this smaller than or equal to the equal sign, and the constraints will be all those ones, and then click. Okay, so I finished adding the all the constraints, and I click OK. So as you can see that I only show 2 constraints here because I grouping the one had the same operator into 1, right? So make sure the make on constraint variable non-negative checked, and changing this to simplex LP, and then you can click solve. Okay, I will stop my video here, and then you can base on this as a hint to help you answer the last question in the attendance check. So the attendance check question is relevant to what is the actual value for your table 3, right? What is the minimized completion time? So that will be on your answer sheet. So that is under the first table, the answer sheet under the called the objective function. That is your result. Your objective function's final value. That will be the answer for that multiple choice question. Good luck.